Welcome, geometry students, to section 3.7, equations of lines. So this is a very essential part. You probably have learned this at some point. This might be review for some of you, but this is going to be an absolute essential for you going forward. Happy Halloween. Hope you guys are enjoying your October. Okay, so we get into the concept of slope here. What is slope? Well, when we're talking about slope, usually, when people talk about it in normal conversation, we're talking about maybe skiing, maybe we're talking about a mountain or a steep hill. Oh, I gave it away. We're talking about the measure of steepness. Measure of how steep, I think it's EAP, something is. I should Google that real quick. Maybe later. Okay, so measure of how steep something is. Now, there's all different ways to represent that mathematically. And the first is kind of the vertical change versus the horizontal change. Okay, so how much we go up and down versus how much we go horizontally. So that's divided by, it's like the ratio of how much we go vertically versus how much we go horizontally. Now, the thing that we probably have seen the most of, or you heard the most of, is rise over the run. So if we're thinking about a mountain, we're thinking about how much it rises versus how much it goes horizontally, how much it runs. Okay, so it's just kind of a quick way to remember. Now, how do we measure how much something rises? Well, let's say we have a point here and a point here. The rise would be just how much it goes from this y to this y. How do you find the difference between those two values? Well, difference in math means subtraction. So we would subtract the y's. Now, it doesn't matter if you go y1 minus y2. Okay, I'm actually going to write it in the way it's normally expressed. Okay, and then for same thing for x's, we find the difference by subtracting. It doesn't matter if we do y2 minus y1 over x2 minus x1, as long as we are consistent. So technically, you could do this over x1 minus x2. The main thing is you can't switch up the order for the ones and the twos. It's got to be 2 minus 1, 2 minus 1, or 1 minus 2, 1 minus 2. But if that confuses you, just stick with the main one, which is y2 minus y1, okay? Now, if you're counting, essentially what we can do, this is why I drew the graph here, is we can count the difference of y's, okay, the rise, okay? In this case, if I'm going left to right, which I like to do, I like going from my left point, starting with my left point and moving to my right, I would count the rise. In this case, it would be a negative rise. And then I always like going left to right, which is always in the positive direction. So my slope here would be negative because I would have a negative divided by, that's an ugly negative sign, a positive. So negative divided by a positive is going to be a negative slope. Okay, so if we had two positives, then it would be a positive slope. Or if we had two negatives, which is the same thing as a positive slope, it would also be a positive slope. Okay, so that's kind of like the intro to slope. We have different types of slope that we talk about. So we have positive slope. Positive slope is slope. Let's do different colors here. Let's start with purple. Positive slope always goes from lower left to upper right. Okay, so that would be a positive slope. We could have a very shallow positive slope. Okay, a very small number for our coefficient of x, or our slope. And then as you can see, this one has a big rise and like a medium run. This one has a very small rise, and this one has a long run. That means it's going to be a smaller slope. If you have a small number on top and a big number on the bottom, the fraction is going to be small. A negative slope is the exact opposite. So let's go, I guess, green, this like kind of neon green here. Negative slope goes from upper left to lower right. Okay, so we could have an average slope there. We could have a steep slope, a very steep slope. Okay, as you can see here, the rise is very negative. It's very steep, big number, compared to its run, which is very small. Okay, now how do you remember rise and run? Let me digress a second. How do you remember? how do you memorize the rise and run is the difference of y's and difference of x's. So you rise with your y's, okay, rise with the y's, and you run from your x. Okay, so if you have an x out there, that's trouble, just keep running. Okay, so that's a way to remember the slope. So we have positive, we have negative, we have zero slope. Okay, there's an asterisk by this one, so let's go ahead and address it in just a moment. Okay, zero slope looks like this. Okay, now there's an asterisk because a lot of people think that it's no slope. If you have a zero slope, that means that is horizontal. So it's not the same thing. Zero slope is not equal to no slope. Okay, it's a horizontal line, and it's in the form of y equals a number. We'll probably get into that a little bit later, but anytime you have y equals a number with no x, then that is going to be a zero slope. Okay. Now, undefined slope is just the opposite. Now, let me talk about zero slope for a second. So if you look here, if we have 2 points, I always like starting on the one on the left, and let's say we have another one on the right. The rise, what's the rise? Well, we don't rise or go down any. Okay, we just stay on the line, but our run is essentially infinite. Okay, so our run, it could be any number because we're always running. But our rise is going to be 0 over our run. We can just say 1. You can always make an integer into a fraction by putting it over 1. And this would be equal to 0. 0 divided by 1 is just 0. So that's why it's a zero slope, because we don't go up or down any. Let's go to undefined. I'm kind of annoyed that I can't. It's right up against the edge. That's why. I was trying to get to the right. Anyway, so what color didn't we use yet? I think we didn't use blue, but that's kind of our color for it. Let's use dark blue. So an undefined slope is the exact opposite. Whoops. What we're going to have is instead of a horizontal slope, we're going to have a vertical slope. Okay. Now, why are we having a vertical slope? Again, let's try to get 2 points here. This time we can't have a left and right because we don't have a left and right. We only have one direction, that's up. Okay, so let's take a look. We would have a rise, let's say like 4, 5, 6, 7. We'd have a rise of 7. But now this time, we're not moving to the left or right at all. So essentially, we could write 7, that's our rise, over 0. I hope you notice the problem. Don't make the mistake of calling this 0. It's not 0. Divided by 0 is undefined. Okay, it's essentially an infinite increase, an infinite slope. It continues to rise and it never runs, so it's an undefined slope. This is always going to be in the form of x equals a number. There's going to be no y. And notice how there's no y-intercept. For horizontal slope, there's no x-intercept. For undefined slope with x equals a number, there's no y-intercept. Okay, so this is a vertical line. All right, so that's the basics of slope. Let's talk about everybody's favorite, which is slope-intercept form, and then we'll call it a day for this part 1 of 3.7. So slope-intercept form, let me just get it set up here. We're going to have equals, we're going to have plus, we're going to have a y, we're going to have an x, okay? And then we're going to have an m, which stands for something, and then we're going to have a b, which stands for something. So the m stands for the slope, that's what we just talked about, and it's always the coefficient of x. And the b is the y-intercept. That's where the graph will touch the y-axis. So this is the y-intercept. And x is just your inputs and y is just your output, so you need to have the x and the y in there. So if you're so confused about mx plus b, just think of it as y equals the slope times x plus the y-intercept. Okay, that's what I used to teach my students, that you don't even need to worry about the m and the b if that's confusing. All right, how to graph. This is kind of like a two-step process. You start with the y-intercept. Now, I forgot to mention something. This is pretty important. You have to make sure the y is by itself for slope-intercept form. So if it's not by itself, you need to solve so that it is by itself on one side of the equal sign, okay? Now, once you have it in that form, we're going to start with the y-intercept. So you always want to identify what the y-intercept is, and it's always the number that's by itself with no variable coefficient. Okay, so here we have the -1. It's our constant. We always want to include the sign in front of it. So we want to include sign in front. Okay, in this case, it is -1. So we are going to go down to -1. Okay, so let's just say this is -1. I wish there was I wish there was little lines on this, but we'll make do. So let's call that 1. We can call that 1, 2, 3. We can call this 1, 2, 3. Okay, that's close enough. Okay, second step. What are we going to do? We are going to use the slope to find. I'm going to put additional, even though you only need 2 points. Sometimes it helps to draw as many points as possible. Additional points. And I'm going to put S in parentheses. Okay, what do I mean by this? Well, first we need to identify our slope. The slope is always the coefficient of x. So in this case, this is our slope. So this is our slope. Forgot to say this is our y-intercept. I should have made that yellow, but whatever. I can do that. Watch this. I'm going to make it yellow. Just stay consistent with my original thing. There, isn't that better? Not really, but. Okay, so that's our y-intercept. Okay, and the important thing with slope is we have to be able to identify our rise and our run. Okay, and if it's positive or negative. In this case, there's no sign in front, so we know its rise is positive. We know our run is positive. Okay, now let's say, just take a side step a second up here. Let's say if it was a -2/3, it might be written just like this. Okay, what do you treat it as? Is this a negative rise or is this a negative run? Well, you get to choose. And what I like to choose is I like to put it in the top and always make my run positive. I like making my run positive. That way I'm always moving left to right. So I'm always moving this direction. It just makes it a little bit easier for me. And then I decide, oh, now my rise is negative, I'm going to go down. But that's not our case here. We have +2/3, so we're going to go up 2 units. Now, where do we start? Well, we start at the y-intercept from our given point. So now we're going to go up 2 units. 1, 2. And then we don't put a dot there. A lot of people are like, oh, I'm going to put a dot there. No, you don't put a dot there. You still have to run. 1, 2, 3. That's definitely not spaced out evenly, but next time I'll put a proper graph in there. And then we plot our second point. So let me actually make this, I'll make it blue. And this is our second point. And you only need 2 points. Again, if you were to do this multiple times, it gives you kind of a better indication of where it goes. But we're going to do our best. Now we connect the dots. Okay, so that's kind of like a third step. I guess we should write it in. Step 3. What is it? Connect dots. And don't just connect the dots and stop. You have to go through. Connect points, we'll say with line. And what I mean by line is it has to go through the point. It has to go through it. Don't just stop it like a lot of people do this. Hold on, let me cut this out. What they do is they just draw it like this. That's tan feo. That's very ugly. So don't do that. Okay, but you want to paste it. And you want to have arrows on the other end because we want to go through infinitely, because this is an infinite representation of all the possible solutions that make this statement true. Okay, so that's slope-intercept form. We're going to get into point-slope form next time, so stay tuned for that. But thank you so much for watching. I'll see you next time.